First of all, I want to thank the organizer of the conference for inviting me to speak, because what I'm talking about isn't part of the regular soybean program. It's one of those alternative projects. And so I really appreciate the opportunity to come and talk about this, because it is a little bit different from production research that's been done. And that being the case, I really want to say thanks also to the Soybean Promotion Board for supporting this work, because it's one of those, what was mentioned earlier, is one of those out there projects. And what I'm going to do in the next 15 minutes is to, first of all, tell you what CLA is and why it's important, and then how we got it in the oil, and then how we found some of the nutritional benefits of it, and then talk about some of the food products that we've made with it, and then talk about where we need to go from there. So that's where we're going to be what we're going to be doing. So, okay, what is CLA? Some of you may have heard about it in the popular media from dairy and beef products, which claim to have this material in called conjugated linoleic acid, which is a long word which really doesn't mean a whole lot. But the reason why it's important is because it's produced by bacteria in the rumen of a cow or other ruminant animals. And simply what happens is dietary linoleic acid, which is in a large number of things, of course, in soybean oil as well, is converted by bacteria in the rumen, and then it finds its way into milk and beef products and deposited there. But it's present in very small quantities. As you can see, less than 1% in milk and 0.1%. So it's a very important substance, and it's been researched, but it's got some important health benefits, but there's not very much of it in those animal products. Well, what is the benefits? Why should we be concerned about CLA? Well, the reason is because it's been found in medical research and nutritional research to have these health benefits. And with cancer and diabetes being major diseases and heart disease, all these factors here are affected and reduced by CLA in studies when we got purified CLA in diets. So it's something that's very important that we should pay attention to. Well, one thing that we do know is that we need 3 grams of CLA a day to get the health benefits that we've just looked at. And so if we were to eat that much CLA from dairy and beef products, we would also be increasing our dietary fat intake and cholesterol, which would be a bad thing. So what we need is a source of CLA that's rich in CLA, but also low in saturated fat and low in cholesterol. So that rules out animal products. So what we thought, wait a minute, soy oil contains about 50% linoleic acid. So it's a huge amount of linoleic acid there. What if we were to find a simple way to convert that to CLA, since that's what occurs in bacteria in much inefficient, a largely inefficient manner? And the other advantage of using soy oil is that we get low saturated fat and no cholesterol. On top of that, it's the most common edible oil in the US. So we then address the issue of converting as much linoleic acid as we can in soy oil to CLA. So as we said, we've got 50% of the fatty acids are linoleic acid. And so we developed this process, and I promised Jeremy I wouldn't use much chemistry. I'll give the absolute minimum chemistry. But what we're doing is a process called photoisomerization. What this simply means is that we're rearranging the molecule of linoleic acid in soy oil, and we're using light energy to do that, to make CLA. And so we're also using an iodine catalyst, which I'm going to mention towards the end of the talk. And iodine is used in the dairy industry for washing. Iodine solution is used for washing vessels in the dairy industry and also in the brewing industry. So there is a history of use of this in the food industry. However, what we did using this system is we developed a pilot plant model. We started in the lab and eventually got to the pilot plant, and whereby we produced a soybean oil that contained 20% CLA. That's a huge amount of CLA when compared to conventional food products that contain CLA, such as dairy and beef products. Anyway, this is the most chemistry I'm going to show you, but the reason I wanted to show you this was because it shows you how minor the change is. Because if we think of linoleic acid just very simply of a string of pearls or a string of beads, there are 18 beads on the chain, And on this 18-beat chain, we've got structures called double bonds. And in soy oil, this linoleic acid is separated by, there's two double bonds, shown by the two double yellow lines. And in linoleic acid, it's separated by one of these beads or a carbon atom. All we're doing is just shifting that double bond so it's right next, so those two double bonds are right next to each other. That's all we're doing. And that's why we get the term conjugated, being right next to it. So that's all we're doing in this process. We're not making any major changes. And this is a diagram that was published in Arkansas Land and Life where they were talking about what we were doing. And it just says, exposure to intense ultraviolet light causes double bonds between carbon atoms in the oil to shift positions. So we get these different kinds of molecules. So that's the theory of it. Okay, how do we do it in practice? Well, very simply, it's just a stainless steel window frame. And we have in this window frame 3 sheets of glass. One there, and one there, just shown in the diagram. And of course, because we've got 3 sheets of glass, we've got 2 chambers. And in one of these chambers, we pump in oil, vegetable oil. And in the other chamber, we pump water to circulate through to cool the system so we can control the temperature of the reaction. And that's what we have there. And we simply do that. We've got this 2-chambered window, if you like, and we put the oil in and flow water through. And this is the system here set up. You can see that you can't see the different panes of glass, but you can see basically what's happening. That we have the light source here shining on this laminar of oil, if you like, or sheet of oil that's cooled with water. And here are 2 lines. One's pumping in the oil, and the other one is pumping in the cooling water so we can control the temperature. Incidentally, the best temperature is about 39 degrees C for this particular reaction to get the most CLA. And this is one of my graduate students. He's just monitoring the temperature with the thermocouple there. And what we want to do, what we'd like to do, and I'm trying to get money to do, is to scale up this so we can have something much more on an industrial scale. We can have lots of these panels. And eventually it's something that probably could be maybe solar radiation driven, rather than using these UV light sources. So that's what we're going on, and we house them in these boxes, and we close the door and we run them overnight basically, and then we've got the oil the next day. And we make sure there's no oxygen in this system so we don't get any rancidity problems. So, having said that, okay, we can produce a 20% CLA oil, conjugated linoleic acid oil, but does it have any health benefits? That's really the question. We know in principle it does because it contains CLA, but what do we know about what this oil does? So, a nutritionist in our department, Dr. Diva Reddy, we asked her if she'd conduct some nutritional animal studies. I'm not a nutritionist, so I wouldn't feel comfortable doing it, and I thought, well, if she does the study, it's going to have more credibility than if I say, well, I tried to stumble my way through a study. So I just gave her the oil and asked her to do the study, and left her with the experiment to design the experiment and how to evaluate it. So this is what she decided to do. There's this particular rat called a Zucker rat, and you can see it's huge. It's a mammoth rat. It's a huge rat, and it's genetically obese. It has genes for obesity. And the reason why medical and nutritional people like to work with this animal is because it behaves the same way as people do. Its genes and everything it doesn't look like a person. I thought about photoshopping a bottle of beer in there or some chips or something, but I decided against it. But anyway, apparently it's a good model for human obesity. So she got these rats in and did the study. And what she did was to take a group of obese rats and give them 0.5% of CLA oil in the diet. Now, the reason for selecting that is, remember I mentioned earlier that 3 grams a day was found to be what humans needed. Well, when you calculate this down to a rat, apparently that is how much CLA that represents. So this is like a genetically obese person getting 3 grams of CLA a day. And then we have another group of obese rats, which is the control. That is, it doesn't get any CLA at all. And so we're comparing it with that group that doesn't get CLA but just regular soybean oil. And then we've got another group of rats which are healthy, normal rats. which don't have any genetic problems, and they're fed the same diet as this group of obese rats that don't get any of the CLA oil. So we've got 3 groups of animals here. And these are fed for 100 days, just a little over 3 months, and then they're sacrificed, and the blood and tissues are analyzed. And when she did the analysis, she looked first of all at the total and LDL-Cholesterol. LDL, of course, is the bad cholesterol that we don't want. And in the lean controls, the healthy animals, of course, it's low. This is total cholesterol. And in the obese rats, of course, it's high. But in the genetically identical rats that were fed the small amount of CLA, we got this 40% reduction in total cholesterol. Similarly, when we look at the LDL, that's the bad cholesterol, we got, well, of course, the lean rats are very low, the obese rats high. When those obese rats were fed 100 days worth of CLA, we get a 50% reduction in LDL cholesterol. So that's huge reduction in LDL in just 3 months. So what we found is that we got a 41% reduction in total serum cholesterol, 50% reduction in LDL serum cholesterol, and thus the CLA improved the heart disease risk factors in these obese rats, which, as I said, is a model for human obesity. So this is very, very good, encouraging data for human nutrition, and eventually we're hopefully going to do something on humans. This is the effect of the CLA and CLA Rich oil on the liver. Now, the thing about the liver in obese persons, the liver fat tends to be very high, a lot of fat in the liver, and the livers tend to be very large. So when we look at the liver weights, we can see in the obese rats, there were 30 grams. In the CLA-treated obese rats, it was reduced quite significantly. So a 35% reduction in liver weight, which was due to the 35% reduction in liver fat, which was induced by the CLA in the diet. So as it says here, non-alcoholic liver disease accounts for most obese persons and most diabetics. So from that point of view, we can see that we've got a reduction in that particular risk factor. If we look at the effect on blood glucose, one of the things in diabetics is that what happens is, of course, there's a high blood sugar, and that blood sugar can react with the red hemoglobin in the blood cells, apparently. And that results in high levels of glycated hemoglobin, which is an indicator of diabetes. And as you can see, we get a significant but modest decline in that particular indicator for diabetes. And also it has an effect on fasting insulin as well, which I don't have the details with me here at the moment. So it looks like from this as well gives some indication that it may provide at that level in the rat over that 3-month period a certain amount of protection against diabetes. So this slide just basically summarizing those 2 points. The 0.5% in the rat diet reduced heart disease risk factors in major ones, and also reduced diabetes risk factors as well. The next question is, okay, it's okay for rats, but we don't want to eat rat food laced with CLA. So how would an individual, a human, acquire CLA in the diet? Well, once it's been approved for production, what kind of foods would we want to include it in? Well, we have made salad oils with it and looked at the oxidation or tendency to rancidity of this oil relative to conventional soy oil. And it's a little different, but nothing major. Sometimes in some studies it looks like it's a little more stable. In others it looks like it's a little less stable, depending what indice of oxidation that we're measuring. But basically there's nothing that would make it incredibly unstable. We've also used soy oil to make potato chips and compare them with conventional potato chips. What was interesting is that when we used the oil for frying, the CLA wasn't degraded by the frying process. That is to say, the oil content and the characteristics of the oil in the chip were identical to the oil that was used before frying. So there was no change in the composition, which means it's pretty stable under frying conditions and therefore should be good in most food processing operations. And we found that there was 39% of the oil in the chips, which is typical. That's nothing unusual there. And this is the two products. And again, they look identical, and in quality evaluation, really not much difference. This is the potato chips fried in CLA Rich Oil, and this is prepared with refined, bleached, deodorized soy oil, which is what we buy in the supermarkets. So what does all that mean? If we can do that process, then if we need 3 grams a day, if we were to just take half an ounce of CLA oil per day, that would give us the 3.1 grams that we need. That's with 20 grams per 100 grams there. It's just putting it in two different terms here. Or in potato chips, we could take an ounce serving, will give us 2.4 grams. And so, you know, I think a packet of chips is about 4 or 5 grams, something like that. So a packet of chips prepared with this 39%, with 39% oil in the chips would deliver that. And that compares with beef, where an 8-ounce serving wouldn't really give you even 0.5%. Milk, even less. Now, we can, of course, increase the CLA from these animal products by increasing the amount that we eat, but by doing so, we're going to increase the saturated fat and increase the cholesterol uptake as well. So the CLA oil offers the benefit of low cholesterol, low saturated fat, high CLA. Now, you say, okay, all that sounds great. Where do we go from here? What are the hurdles towards taking this the next stage? Well, the first one is I mentioned earlier that we're using iodine as a catalyst, and in the studies that we've been doing, we've been using adsorbents, commercial adsorbents that are used for regenerating frying oils and that kind of thing, to take out the iodine. But that's not very practical on an industrial scale. We want really to have something that's a continuous process that we can take the oil through the frame, off the frame, through a system, and then have the oil finished. And ideally, what we'd like to do is to have an almost commercial scale operation of that type and have that operation. So that's the thing that we're addressing, we want to address now. The other thing is to look upon this CLA not just as a food, but also as a pharmaceutical, or at least what they call a nutraceutical, which is a food component that has valuable drug properties. So that's something that we want to look at, because that may produce a lot of profitability for the soy industry as well. The other thing, third thing that we're very, very interested with is to cooperate with major soy oil companies. And throughout this project, I've been in touch with ADM, Cargill, and Frito-Lay. And I run into these guys at meetings, professional meetings that I'm involved with and committees that I'm on. And I talk to them after the meeting, and also in kind of taxi rides between the meeting and the airport and things like that. So we've got these informal discussions with these industry leaders going on, as well as periodic emails of updates and things like that. So that's really what I want to do, is to intensify that level of communication, really just to get them aware of what's going on in more detail, and to provide the business and financial input that are needed to really move it from just an interesting lab operation to something that's really going to be a commercial viable project. So the first thing that we do, and this just happened this summer, one of the things you learn to do when you get some grant money is how to leverage it and how to stretch it. And it just so happens I had access to some students and funded from Europe, and so I got them on this project. And I was working with a chemical engineer who's an expert in membrane separation. That is, basically, you've got a mixture of materials in liquid form, and you put it through a membrane, and you selectively lose those components through the membrane that you want to get rid of, and you retain the ones that you want to keep. So, working with Dr. Beidel, who's a membrane specialist, we developed or found a molecular filtration process. And we've only tried one membrane so far, so this may not be the best membrane to look at, but it certainly works. We found that we could get the iodine to leave the oil and leach out, and we still retain the oil. Sorry, get the iodine to leach out and retain the oil. So we know it works in principles, but we need to find the best membrane and scale up operation, because the beauty of this system is that we can have hollow tubes and flow the oil down it, and the iodine will leach out, and we can have a continuous system of oil coming off the frame, going through a filtration system, and then having the final product at the end. At least that's the dream that we would like to do, is to be able to just have this continuous flow industrial process. So we think we can do it in principle, and the way that we've been just evaluating membranes, anyway, we've been using this system, putting the oil iodine that we've used with CLA and pumping nitrogen in it to produce a pressure, and then filtering out the bottom there and seeing how much we can leach out. And there we've found some of the iodine that we've managed to get out, and there's no oil in there, it's just straight iodine. So we know in principle that we can do it, we've just got to find the best way to do it. And that's why I'm getting involved more with the industry on this particular project. Okay, the other thing that I mentioned is making pharmaceuticals from this CLA material. Well, I have a graduate student who's figured out how to chop off the CLA from the oil molecule, the triglyceride, and then concentrate it and as a pharmaceutical product. And what he's doing now is looking at the detailed chemistry of that to see exactly where those double bonds are, make sure they're exactly where we think they are, because we need to know that for before we can move ahead on any pharmaceutical application. We need to know very clearly what the molecule is. The other thing is, we don't have enough money to do another animal study on the purified CLA, but we are going to do a cell culture model, seeing what the effects of purified CLIs on the biochemistry of animal cells. And again, this is going to be Dr. Diva Reddy's lab who's going to conduct these studies, and one of her graduate students is going to do that. Having said that, we then need to scale up this again to get to where we can say, okay, we can do it in a small scale to do a cell culture. We need to scale it up for commercial viability, and also to enable us to do more fat rat studies, if you like, those obese rat studies, but on concentrated CLA. The other thing was the soy oil producer contacts. As I say, we've been in regular touch with these companies that are mentioned there, and I forwarded the information that I've just presented to you to a guy I know at Cargill who heads up the sustainability unit there, and he was very interested. He responded to my email within a few hours, and was very interested in pursuing the relationship in terms of developing, seeing what the commercial viability was. And from my experience with working with these guys, they're very good at pinpointing those issues where you need to focus on. And some of the things that, like the iodine issue and the nutritional study issue, were things that were highlighted by my conversation with various companies, which are kind of guiding the direction. So we're going to have a phone conference sometime before Christmas to kind of see if it's going to be worth his while to come down to Fayetteville and look at our operation and have a site visit and discuss further collaboration. And I'm hoping that we can get involved with ADM and Frito-Lay, and the Cargill contact even mentioned Unilever. Thought you may be able to get Unilever interested as well. So that's where the project is at the moment, and these are the things that I'd like to pursue to really bring it from being just a lab project to being a real commercial opportunity. And of course, I want to acknowledge the support of the Arkansas Soybean Promotion Board. Without this, they've really been great at providing the foundational support for this project, in addition to USDA and one or two other project funders. But they've really been tremendous. I want to thank them for making this project go as far as it has done. And if there's any questions.
Any questions for Andy?
Do you ever find anything negative that the CLA has a negative consequence?
Well, I tell you what, when we were doing the rat studies, I was phoning the guys doing the study and asking if the rats are still alive every day. I was phoning them up every few days, because this stuff has never existed before. I wanted to make sure none of them died before they were killed. That was, and no, none of them died. They were all. So I was asking, when you present this kind of presentation, I'm always very upbeat, but I'm paranoid, so. So I was asking them. We also did a catfish diet with Dr. Lockman, and when I gave her oil, And I was phoning, are the fish okay? Are the fish, it was like they were my kids, you know, I was wanting to know they're okay. And all the fish just behaved, in terms of the general health, were just as like any other fish raised on regular soybean oil. There were some risk factors that weren't improved, like, for example, the weight loss really wasn't very marked in the animals. So basically, we didn't come across anything really bad, but there were some risk factors such as weight loss didn't really have a big effect on. I was so concerned about any residual iodine. That was my real concern. And so I asked her if she'd check the thyroids of the animals out. That's where all the iodine is concentrated. And they did some tissue analysis of that, and the thyroids looked normal. So, I mean, I'm not saying famous last words, you claim that they're perfectly safe, but everything that we've learned so far doesn't show any negativity. Some of the risk factors are reduced more than others, but by and large, it looks pretty good. My main concern is to get as much of the iodine out in an efficient industrial process. That's what my main interest is right now. Okay. Any?
I have one comment. You heard me mention those new uses as part of the things that we fund on the board, and some of those things that were out there. This is one of them. And what I saw is that this may be a project that we need to send to USB. I believe it has some
well, I had an experience. Yeah. A few years ago, they contacted me, and I submitted it, and I never heard anything. So.
But you didn't have healthy rats at that time.
No, that's right. We didn't have any rats, no.
The other thing is, what I saw out of this is on a practical level, is we can make fast food healthy again.
Well, that's a good point. When we published a paper on the chips, and one of the reviewers said, "Do you really want to have potato chips?" saying it's a healthy food. I mean, that's why I didn't, if you notice, what we had for lunch wasn't a salad, and we didn't use salad oil. We had fried catfish. So that's what we've been thinking about, catfish and frying catfish. Because that's where people are not going to eat food that they don't want to eat, just to be healthy in reality. But chips may not be the best food, but it's certainly something everyone's going to eat.